Let's make Wordle in 1 hour using GameMaker. This is what the end result is going to look like. It's going to use an actual word list, so you can't enter any random letters. It has to be an actual 5-letter word for it to count, just like the actual Wordle. So let's begin. Let's create a new GameMaker project. This will be a blank GML project. And by the way, I haven't prepared any code for this beforehand, so we'll figure this out as we go. In the project, first of all, I'll be creating a new object and name this Wordle. This will basically manage our Wordle game. I'll open the room and drop the Wordle object there. We need a square room though, so I'll change its size here to 960 by 960. It's an arbitrary size, but at least it's a square. Now let's go back into the object and start coding our Wordle system. We're gonna begin by creating two events, create and draw. In create, we're gonna set up all the variables and data that we need. And in the draw event, we're gonna draw the grid and all the letters and all that. So let's begin with the create event and start creating some variables. First of all, we need width and height. So the width currently is 5, which is how many cells you have in the grid horizontally. Because Wordle is about 5-letter words, the width is going to be 5. And Wordle gives you 6 tries, so you can enter a 5-letter word 6 times. So that's the vertical size of our grid, which is the height. Then let's also create a variable for the cell size, which is the size in pixels of one cell in the grid, and then a cell gap, which is how much separation there is between each cell in the grid. So that's the variables we're gonna create for now. Let's move over to the draw event and draw our grid. For this, I'm gonna create a for loop that goes through each cell in the grid. So the first one will be about the horizontal component of the grid and will go from 0 on the x up to the width minus 1 to be accurate. Now I'll copy this loop and paste it inside it. This one will be for the y component, and this will go from 0 to height minus 1. Now inside these loops, we'll have the code that draws each cell. So first we need to figure out where the cell will be drawn. So let's create variables for that, draw x and draw y. Now the draw x will start at the x of the instance, and to that we'll add the local x multiplied with the cell size plus the cell gap. So that's how much we'll increment each iteration of the loop to get to the next cell. Now let's do the same for the y, where of course the calculations are the same. We are just using the y position of the instance and the local y variable from the loop. So now that we have the position of the cell, we should draw a rectangle there. So I'm gonna call draw rectangle, and for the top left position of the rectangle, I'm gonna pass in draw x and draw y. And for the bottom right position, I'm gonna pass in draw x plus cell size and draw y plus cell size. That's simple enough. Now the last argument is whether we want it to be an outline or a filled rectangle. I want it to be an outline, so I'll pass in true for that. This should now draw our grid, so let's run the game and see how it looks. Okay, so we can see the grid, so that part is working. However, I'll change some properties back in the create event. I'll reduce the cell gap to 10 and increase the cell size to 120. Let's see how this looks, and it's definitely looking a lot better, so I'm gonna keep these settings for now. Now each cell in the grid will of course contain some data, and we'll store the data for all the cells in the grid by creating a 2D array. Now the data in each cell won't be a regular number or a string, it'll be a struct. Now if you don't know structs, a struct in GML is basically a group of variables. So if you have a struct for each cell, it means that you can store many different kinds of variables in that cell, and so you can store different kinds of information in one place. You're not just limited to one single value. And so for Wordle, each cell in a grid contains the letter that it shows and its state. Now there can be 4 states. It's either inactive, meaning that cell hasn't been checked yet. It can be wrong, meaning that that letter doesn't exist in the word. It can have an exist state, meaning that that letter exists in the word, not at that place but at some other place. Or it can be correct, meaning that the letter in that cell is at that exact spot in the word. So the colors for these, if you've played Wordle, you'll know, are green for correct, yellow for exists, and just gray for wrong, and a darker gray for an inactive cell. So the letter or character in the cell and its state are the two variables that a struct for a cell will store. and it'll also have a function called draw, which will draw the contents of that cell. So that includes its character and a colored rectangle showing its state. Now to create a struct in GameMaker, you can first create a constructor, which is basically a template for a struct. It tells you what variables and what functions a specific type of struct can have. So we're going to create a constructor for a cell struct. To create the constructor, I'm going to create a new script assets, and I'll simply name this classes. It's going to open up here in the workspace, but I'll click on full screen here to open up in a separate workspace. I'll also go back to the object and make this full screen, so it's opened up in another workspace. This makes it easier to work with separate events and scripts. So let's go into the classes script and create a constructor. A constructor is created just like a function, but it then has the constructor keyword there. So this constructor is called cell. Now the first variable it has is the character that it stores. So this will be named char, and by default it'll store an empty string, so there's no character there. Then the second variable will be the state. So I'm gonna set this to 0, but we should set up an enum for the states, and an enum is simply a way to give your values a name. So if you just want your states to be regular integer numbers, 0, 1, 2 and 3, that's fine. But it can get a bit hard to remember what 0 stands for, what does 1 stand for, what does 2 stand for, and so on. So it's helpful to create enums, which are just global constants. You can just reference them, and they are just integer values under the hood, like 0, 1, 2 and so on. And they are mostly used to create states like we are doing here. So I'll name this enum cell state, and it will have 4 members. The first one will be inactive. That's when a cell hasn't been activated. The second one is wrong, when the character doesn't exist in the target world. The third one is exists, which is the yellow one, and the last one is correct. Now in the cell constructor, I'm gonna set the state to be equal to cell state dot inactive by default. That's how you use an enum member, by having its enum name first, then a dot, and then the name of the member that you want to use. So behind the scenes, this enum is just 0, 1, 2 and 3, but you don't have to remember the numbers anymore. Now let's also create a function in this constructor. This will be a static function. We are making it static because this function doesn't need to change for each struct. This function will be the same for each struct that is created from this constructor, and for that purpose we're gonna make it static. For example, the variables that we have above this, char and state, they are not static because each struct can have a different value there. Each cell can have its own character and state, but that doesn't apply to the function. So the draw function takes 3 arguments, the x and y position and the size of the cell. Now in the draw function, we need to draw a rectangle first of all. So this will be drawn at the x and y position passed into the arguments, and it will use the size also passed into the arguments. This will be a filled rectangle, not an outline, so the last argument here will be false. Now this is the colored rectangle that we were talking about. This will be yellow or green or gray depending on the state of the cell. So we need to set up the colors for each state without having to figure it out in the function. We just need to create an array that stores the color for each state. So at the end of the script, by the way, if you add something in a script that's outside of a function declaration, it's simply going to initialize it at the start of the game. So a script is a good place to initialize all of your global variables and constants. Now I'll name this array global.colors, and for the array index we're going to use the cell state enum. So first of all, for the inactive cell state, the color will be black. Then for the cell state that is wrong, the color will be dark gray. Then for the exists cell state, the color will be yellow. And finally, you know this one, the color for the correct cell state will be green. So we can now simply reference this array in the draw function in a cell struct to get the color that corresponds to the state of the cell, and then draw a rectangle using that color. So here in the draw function, I'm going to create a local variable called color. This will get the color from the global colors array using the state of the cell as the index. Then I'll call draw set color to change the draw color to the color that we got from the array. draw a rectangle, and after drawing the rectangle, reset the color back to the default color, which is white. So this should now draw a filled rectangle with the color that belongs to the cell state. So this defines our cell and what data and functions each cell will have. Let's go back into the Wordle object now and set up the structure of our grid. This will be a variable called grid, which will simply be an array. It'll actually be a two-dimensional array. We need to loop through this array to initialize each cell. So for that, I'll just go into the draw event and copy this for loop because it's going to be exactly the same. I'll paste it here, add the closing brackets, and now inside the for loops for each cell, I'll initialize the position in the grid array, add the x and the y defined by the loop, and that value will be equal to a new cell struct. So when we say new and then call a constructor, we are just creating a new struct from the constructor that we are referencing. So the cell constructor, which has char, state, and a draw function, that default data will essentially be duplicated into a brand new struct and applied to this position in the array. Now to reference a position in the 2D array, you can either use this syntax or you can use the older syntax with a comma in the middle, but I'm gonna stick to the latest GML syntax. Now back in the cell constructor, in the draw function, we are drawing the filled rectangle, but we're not drawing the character yet. So let's add a comment here that this is for drawing the filled rectangle, and then add a new section for drawing the character. For this, I'll simply call draw text. For the position, I'll pass in the x and y from the arguments, and for the text, specify the char variable. And now in the Wordle object, let's make sure that each cell is drawn. So in the draw event of the Wordle object, inside the for loops, after we draw the rectangle outline, I'll get the cell from the grid using the x and y of the loop, and then on the cell I'll call the draw function. So it's this simple to actually call a function from a struct. You simply do struct.function and it runs the function from inside that struct. Now to this function, I'll pass in the draw x and draw y values, which is where the cell should be drawn, and also pass in the cell size as the size argument. This should now draw each cell in the grid. Let's run the game and see how it looks. And we are currently, of course, not seeing anything because the character for each cell is an empty string, so no letter is drawn, and the state for it is inactive, which simply has a black color, so you're not going to see any colors here right now. But to test that our system works, let's go ahead and change the default character to A and the default state to correct. Let's run the game again and see how it looks. And you can now see that we have all the cells turning green and they are showing the A character. One problem I can see is that we're not seeing the outlines for the cells. That's because we are drawing the outline before the cell. So I'll move it from here to being drawn after the cell. I'll add a quick comment here. And now let's run the game again. And we are now seeing the outlines. So that's great. Let's go back into the cell constructor and revert these variables to their default values. So the character string should be empty and the state should be inactive. So now we have a grid with its structure and data set up. So we need to work on the logic now. So what is the winning word that the player needs to input? Which cell are we currently on? And also allowing the player to press a letter key on the keyboard, entering that into the currently selected cell, and then moving to the next cell. So let's begin by adding some variables in the create event of our object. First of all, I'll add target word, which is the winning word that's required to win the Wordle game. For now, I'll set this to power. Later, we'll add an actual word list, and the target word will be selected randomly from that list. So any word can show up as the target word. Then we have the current line. So which line in the grid are we on? And then we have current cell, which is the current horizontal cell that is selected. This also starts at 0. So the first cell or the first letter is 0, the second one is 1, then 2 and 3 and so on. Now let's go ahead and add the step event to this object, where we'll have our main logic, allowing the player to input any letter. So I'll start by creating a local variable that stores which letter key was pressed, and we get that from the keyboard last char variable. This built-in variable stores the character that was last pressed. So we get that, and now we need to detect whether any key was pressed. So here I'll simply add an if condition, and this will use the keyboard check pressed function. to check whether any key was pressed. So of course this is going to cover all the letter keys. Now here, to allow the player to input a value, we need to make sure that the current row is not already filled, that there are spaces remaining. So to check that, I'm going to add another if condition, and this will check if the current cell value is smaller than the width. So that means that we haven't filled the currently selected row. If that is true, we are going to first of all reference the current cell from the grid array. So for the x component we use the current cell value, and for the y component we use the current line value. You can see how the cell value is horizontal, so it corresponds to the x, and how the current line value is vertical, so it corresponds to the y value. Then we set the value at that grid position equal to the character that was just entered. Now our main condition up there checks if any key was pressed, and that any key can be a key that's not a letter key. So we need to ensure that a character was entered. So up here in this condition, I'll add another condition, join it using and this will essentially check whether the character string contains any letters. To check that, we'll call the string letters function, which basically returns all the letters that it finds in the input string. So if it doesn't find any letters, it means that a letter key was not pressed. So in this condition, we need to make sure that the value that that function returns is not equal to an empty string. If it's not equal to an empty string, it means that it found a letter in the character string, and so we can actually use that for the cell in the grid. Now in our Wordle system, we are using uppercase letters only. As you saw, the target word, which is for now power, is all uppercase. So we're gonna convert the character that was entered into uppercase as well. So for that, I'll use the string upper function and wrap it around the character string before applying it to the cell in the grid. Now let's run the game and stop. I found a mistake there. Here I'm setting the entire grid value to the string, but that's not what we need to do, because a cell doesn't just contain a string, it contains a struct that contains a string in its char variable. Because as you can see in the create event here, it's a struct, it's not just a string, and that struct contains the char variable. So the char variable is what we need to set. This is a common mistake to make whenever you're using structs. Sometimes you're just gonna override the whole struct with a singular value, and you just need to make sure to apply a value inside the struct. So here I'll apply the value to the char variable inside the struct. Again, we are using the dot notation here to reference the variable that we want from the struct. Let's run the game now, and if you press a key, you'll see the letter being entered there, but it remains on the first cell and doesn't move because we are not actually incrementing the current cell value. So within this same block where we apply the string, let's increase the current cell value by 1. Let's run the game again. And I'm now able to enter a word throughout the whole row. So I've written hello there, and once I finish the whole row, I'm not able to enter any more words. So we can now go ahead and add other features like adding a backspace functionality so you can erase the word that you entered last, and also to allow the player to hit enter and verify the whole row, see if it matches the word. We are going to do all that, but we are first of all going to improve how this looks. Currently it draws with the default GameMaker font. It draws in the top left corner. It looks very small. We want it to look a bit like the actual Wordle game. So to make it look better, I'm going to start by creating a new font asset, and in its editor I'm going to select a font that I like. I'll make this font really big, so let's say 80. And in the classes script, in the cell constructor, before drawing the chart text, I'm going to change the font to the new font asset that I just created. Now we also want the text to draw in the center of the cell, so I'll first change the horizontal alignment to center and the vertical alignment to middle. They're essentially the same, they're just different constant names for the horizontal and vertical alignment. I'll copy this and paste it after drawing the character, where I'll reset the alignments to their default values, which is left for horizontal and top for vertical. Now we also need to make sure that the coordinates where the text is drawn are in the center of the cell. So to get that, I'll simply add half the size to the X and the same value to the Y. Let's run the game now and see how it looks. And it looks so much better with the big font filling the cell, and it looks very close to the actual Wordle. Now we're gonna work on the game's logic, allowing the player to hit enter and have the game check the word that they entered. So we're gonna assign a state to each cell based on whether the letter in that spot is correct, whether it exists or if it's wrong. So we're gonna go into the step event, and here before this block I'm gonna create a new conditional block, and here we are going to check if a key was pressed. The key is enter, so on hitting enter your word will be checked. And in this block we are going to call a function which will create later in the create event, and that function will check the word that the player has entered. Let me fix this bracket here, and I'll make this one an else, so the second condition will only check if the first condition is false. Now when enter is pressed, I'll call the check line function, which will check the line that we are currently on. Now this function will be created in the create event, so this is a method that's specific to the Wordle object. So a method is basically a function that's specific to one object. I'll create a section for the methods here and create the check line function. And in this function we're going to go through all the cells in the current line, check whether the letter in that cell matches the letter in that spot in our target word, which is power currently, and we're gonna assign a state to that cell based on a set of conditions. I'll create a for loop. The loop variable here will be called char to tell us which character number we are on. It will go from 0 up to the width, or width minus 1 to be accurate. Now inside the loop I'm gonna get the cell at that position. The line will be from the current line variable. So what we got here is a struct. So from that struct we need to get the character letter. Now while going through this loop we want to create the word that was formed from the letters that the user entered. So before the for loop I'm going to create a local variable, and I'll name this formed word. It will be an empty string in the beginning, and inside the loop I'll add the character that we got from the struct onto this variable. So by the end of this for loop, the formed word local variable will contain a 5-letter word. Now we want to check if the character that's in this spot is the same as the character that's in the same spot in the original target word. So first of all, I'll get the correct character from the target word. I'll do this using the string char add function, which is used to get the character at a specific position in a string. So I'll pass in the target word for the string that we are getting the character from. And then the second argument is the position in the string where we are getting the character from. So for that, I'll pass in the char variable that is being controlled by the for loop. Now this char variable in the for loop begins at 0, but the string functions for GameMaker expects a value that starts at 1. So to make sure this works correctly, I'm going to add 1 to this. Then I'll add a condition that basically checks if the correct character and the character that we got from the user's cell are the same. If they are, it means the user entered the correct character. So in that case, I'll set the state of the cell to cell state.correct, because the letter that's been entered in this cell was correct. Then I'll add an else if block to check if the character exists anywhere in the string, in which case we'll give it the yellow state. We do that by calling the function string pose, which returns the position of a substring within a string. And so that's how we can actually check if a specific character exists anywhere inside the string. So the first argument here is the substring that we are searching for, which is the character that the user entered. And then we have the string that we are searching through, which is the target word. Now this function will return a value of 1 or above if it found the character, or 0 if it didn't find it. So if it found it, the value will be greater than 0, and that's what we are checking for in this condition. If that is the case, I'm going to set the cell state to cell state.exist. Now if none of these conditions are true, it means that the letter that the user entered is not correct. It doesn't exist in the string anywhere. So we're going to add an else block here and set the state of the cell to cell state.wrong. So now this for loop is going to go through the whole line that we are currently on and apply a state to each cell depending on the letter that was entered there. Now when the for loop ends, we're gonna check if the player has won. So here we are basically gonna check if the formed word is the same as the target word. If they are the same, I'll call a win function, which will create later. I'll create a placeholder for it right now, just an empty function. But if the player didn't win, we're gonna allow them to move on to the next line and try again. So I'm gonna add an else if block, and here check if the current line is smaller than the last possible line, which is height -1, meaning that there is one more line left to go. If there is, we're gonna increase current line by 1. If that is not true, it means the game is over, the player has run out of all rows. So for that, I'm gonna add an else block here, and here let's call a lose function. I'll create a placeholder for that here as well, just an empty function called lose. And now our checkline method is basically ready. I'm gonna add some comments here. Now let's go back into the step event. Here we are checking if the player has pressed enter, but they should only be able to press enter if they have entered all the letters into the current line. So onto this condition, I'm gonna add another condition using and this will basically check if the current cell is equal to the width of the grid, which means that all of the cells have been filled. So with this, let's run the game. I'll enter hello, hit enter, and we've got an error. It's unable to convert the string h into an integer. It's on this line, which calls string char at. Let's see what's going wrong here. And the problem here is that here we are getting the character from the cell and we are naming this variable underscore char. But the variable that we are using in the for loop is also called the same, which tells us the character number that we are on. So because it is the horizontal components of the grid, I'll change this to underscore x. So it should change everywhere in the loop's header, and also here where it needs to know the horizontal position of the character, and then in this function where it needs to know the position to get the character from the target word. Another problem is that after moving the player to the next line, we are not resetting the cell number, so they should be reset to the first cell on the next line. And now I'll run the game again. I'll enter hello and hit enter, and you can see that E and O are highlighted as yellow because they do exist in the word, but H and L, they are gray because they don't. Now I'll enter a word that's close to power, and you can see that O, W and E are green because they exist at that position in the target word. Now I'll enter some other word, and you can see that P and R are yellow because they are in the word but not at those positions. Now I'll enter power and it's all green because the word is correct. Now I do think that the yellow that we use for the exist cells, it's too bright. We can't really read the letter that's on it. So I'll go into my classes script, and here where we initialize the color for the exist state, I'll change it to use the merge color function, which allows us to mix two colors. And I'll use this to mix yellow with black and use half of both. I'll run the game again. I'll enter hello, and you can see that the color looks a lot nicer now. Now if the player makes a mistake, we need to allow them to hit backspace and erase the letter that they entered last. So I'm gonna go in the step event and here add a condition for when the player presses the backspace key, and I'm gonna make this one an else. Now when that happens, we are gonna check if the current cell is greater than 0, meaning that we have at least entered one letter, and in that case I'm going to set the character at the current cell on the current line, and can set its char variable to an empty string. So it's gonna erase whatever character's been entered on that cell, and then we're gonna reduce the current cell variable by 1, so the player moves back one cell to where they were previously before they entered the last letter. And actually this should come before this line, so the current cell value should be subtracted first, and then the cell that we go to should be emptied. So let's run the game. I'll enter something, hit backspace, and we're able to erase whatever we have entered in the previous cells. Now one problem is that when you win, when you figured out the word, you can still hit backspace, so that shouldn't be allowed. When you win the game or when you lose, the game should be deactivated so that you can't do any more inputs. So for that, let's go into the create event and create a variable called gameActive. This will be true by default, means that the game is active. Then in the win function, I'll set it to false, and I'll do the same in the lose function as well. And then in the step events at the very top, I'll check if gameActive is false, and in that case I'll exit the event. So the step events won't run at all when the game is not active, and so the player won't be able to give any inputs. Let's run the game. I'll enter the correct target word here, and now I'm not able to hit backspace or do anything because the game is not active anymore. What we need to work on now is to make it so that the player can only enter a valid 5-letter word. They can't enter any random string of characters, but it'll check from a list of actual 5-letter English words and make sure that what the user has entered actually exists in that list. So for that, I'm just going to Google JSON of all 5-letter words. Hopefully we can find a JSON file or a file in another format that contains 5-letter words. And let's look at this. Seems to contain all the 5-letter words or many 5-letter words, and this should be good enough for this example. I can't guarantee that this will contain every single 5-letter word that is allowed on Wordle, but it should be good enough for this demonstration. So I'll save this file. I'm gonna paste the file in the data files folder of my GameMaker project, and it should now show up in the included files of your project, which we can now load when the game is running. So I'll create a new script for this and name this all words, and in this script I'm basically going to load all of the words in that text file into an array. So because this video is getting too long, I'm gonna jump ahead to where the code for this script is finished, and we'll go through how it works. So here I'm creating an empty array called valid words, which contains all the valid words that can be entered, and then I'm opening a text file to read it. I'm entering the name of the file here, and then I'm running a do until loop, which runs until we've gone through all of the lines in the text file. Then for each line it reads the line and it runs string copy on it so that it copies exactly 5 letters from that line. It doesn't copy, for example, a line break character. It only copies the 5 letters that we need on each line, and then it pushes that into the valid words array. Then when the loop is over, it closes the file, and then for testing purposes it prints the array to the output log, which we can see at the bottom. The array contains all of the 5-letter words from the file. So now in the create event, in the checkline method, we need to check that the word that the user has entered is valid, that it exists in the array that we loaded. Now this for loop goes through all of the cells in the current line, and it creates the word that the user entered, and it also sets the state of each cell. We need these to be separate. We want a separate for loop to first form a word, and then a second for loop to set the state of each cell, and the second one would only run if the user has formed a valid word. So I'm going to copy this for loop, paste it here. I'll change the comment so that this one is for checking the formed word, and this one is for setting the state of each cell. Then from the second one, I'll remove the addition to the formed word variable, so it only sets the state. And from the first one, I'll remove the code that changes the state of the cell. Now after the first for loop is done and the user's word is formed, we're going to check if that word is valid. And now how do we actually check that? We can loop through the array and check against each item in the array to make sure that the word that the user entered exists in the array, but that's not the most efficient solution. I think this is somewhere we can make use of structs. So instead of each word being an entry in an array, it can actually be a unique key or variable in a struct, and so we can then simply just check if the word that the user has entered is in the struct as a key, and if it returns undefined, it means that it doesn't exist in the struct, and so the user hasn't entered a valid word. Let's go back into the all word script and change this to a struct by using these curly brackets. And here, instead of using array push, because it's not an array anymore, I'm going to use the struct accessor, pass in the word to create a key or a variable, and set its value to 1. The value here is irrelevant. We only need the key to exist in the struct. I'll remove the show debug message call. And now let's go back into the create event and here check if the word that the user has formed exists in that struct. So here I'll add an if condition. I'll mention the struct, use the struct accessor, and pass in the formed word variable. So this should return the value of that key in the struct, which for all of the valid words is 1. But if the variable doesn't exist in the struct, then it will return undefined, and that would mean that the word entered is invalid. So in this condition, I'll check if the word that's returned from the struct is not undefined, which means that the user entered a valid word. Actually, let's turn this into checking if it is undefined, and in that case, we'll show a message to the user and say that it's not an actual word, and then return so the function ends. Quick side note, the show message function shouldn't be used if you're releasing your game. It's only meant to be used for testing purposes. So if you need an actual dialogue for your game, it would be much better to make one of your own instead of using this function. Let's run the game now. I'll enter hello, hit enter, and it's saying that this is not an actual word when it is. So there's a problem here. So the problem is that the text file uses lowercase letters, but in this game we use uppercase letters. So before passing our formed word into the string, we should convert it all to lowercase by calling string lower on it. Now let's run the game again. So I'll enter hello, hit enter, and it worked. I'll enter a random string of characters, hit enter, and it's not an actual word. So it's now using the file that we loaded to check if the word that the user entered is valid. Now up here we are setting the target word to power, so we are manually setting the word that the player is looking for, but this should also select from the list that we loaded and just load a random word, and that's how the game begins. Now loading a random variable from a struct is possible, but that's not the most efficient solution. In that case we should use arrays. So I'm going to go back into the all word script and create a second variable. This one will be an array, so I'll call this word list. And for each line in this do loop, I'll use array push again to push the word into the array. Now in the create event, I'll comment out this line, create a new one. Here I'll set target word to be retrieved from the word list array. For the index, I'll use the array length of the array, subtract that by 1 to get the last element, and then wrap that in irandom so it gets a random value from 0 up to that value. Now it will be lowercase. Our system uses uppercase letters, so I'm going to wrap all of this in string upper. So ultimately what we get is an uppercase string, and now the target word will be random. So let's run the game, and the word that's been loaded now is random. I have no idea what the word is, so we can try and guess using our own Wordle game. Now for the next few minutes before we move on to animation, we're going to work on fixing a problem to make sure that our Wordle game works perfectly. So what we want is that if this E is the only E in the target word, then the E that we entered in the third slot should not be yellow, because we've got the only E correctly. So we're going to incorporate 2 additional things into our checkline method. The first is that if you get a letter correctly, if you've guessed the E here, then it should be removed from the string that we are checking, so that any E's that we entered after that don't catch that and show it as yellow. The second thing is that if we entered an E in the third slot and it only exists in the fourth slot, then it should first check if we have guessed it correctly on the fourth slot, which we have done in this example. So in that case, it shouldn't show the third slot as yellow. But if we haven't guessed it on the fourth slot correctly, then it should show the third slot as yellow. So let's work on that. Down here in the checkline method, before this for loop that sets the state of each cell, I'll create a variable called temporary target word. So this is a temporary variable that stores the target word, and we can remove letters from this string instead of modifying the original target word. Down here, instead of checking string pose on the target word, we'll check it on the temporary target word. Now again, because this video is getting too long, I'm going to jump ahead where this modified code is finished, and we're going to go through how this works. First of all, we're getting the correct character that is in the temporary target word at the position that we are currently checking through the for loop. Then using string post, we are looking for the character that the user has entered in this slot in the temporary target word, and we are storing the position of the character that's found in a local variable. Now first of all, it checks if the character that's been entered is the correct character, which means the user guessed this letter correctly. In that case, we set the state of the cell to correct, which we were doing before. But here what we are doing here in these two lines is that we are deleting the word that we guessed correctly from the temporary target string, and we are replacing it with a hash or a pound symbol, because we can't just delete it. That would change the size of the string, that would bring it down from 5 to 4, and so our system would break. So we are replacing it with a hash symbol so that the letter in this position is essentially gone. Now the second condition here, as before, checks if the character that the user entered in this slot was found anywhere in the string by checking if the position for that is greater than 0. Now within this we have another condition. In this condition, we are getting the letter that the user entered at the position where we found the current letter, and we are checking if it is not the same as the character that's been entered in this one. If it is the same, it means that because it exists in the target word at that position and the user also entered the same word at that position, they guessed it correctly, and so we shouldn't mark the current one as yellow or exists. But if it's not the same, it means that the user didn't guess what letter is at that position, and so we can go ahead and set the cell state to exist. In this case, we also delete the letter that the user has guessed, and we replace it with a hash symbol so we don't catch it again. And then here, ignore the show debug message call. This was just added by me during testing. And then we have an else block here, and this runs if the position where we found the current character to exist has been guessed by the user. So in that case, we set the state of the current cell to wrong. And then as always, we have the final else block that just sets the cell state to wrong. Now just for a test, let's comment this out so we can enter any word, and let's set the target word to bread. Now we're on the game. I'll enter this here, and you can see that the A is yellow because it exists in the word, but only one A is yellow because there's only one A in the target word. Without our new code, all of these three A's would be yellow, but that's not the case anymore. Now I'll enter this, and this is where I've guessed the A correctly, and in that case the A before that is not yellow because we have guessed it in the fourth position where it actually does exist in the word. So this way our detection system is a bit smarter than before. Now we are finally going to work on animation so it doesn't look as basic as it currently does. I'm going to re-enable these lines so you can't just enter any random string of characters. And let's work on animation now. I'll create a variable here called animating, and this will tell if we are currently animating or not. This will be false by default, and over in the step event at the top, the event will exit if animating is also true. So while the game is animating ourselves, we won't be able to enter any more letters. Then in the create event at the end of the check line function, I'll set animating to true, so the animation starts when we hit enter. I'll create a variable called animation delay, and this is essentially the delay between each cell animating. So the second cell starts animating 60 steps after the first cell, and so on. For animating ourselves, we're going to use alarms. So one alarm will be called, it'll animate one cell, then the same alarm will be called again, which will animate the next cell, and so on until all of the cells in the current row are animated. So here I'll set alarm 0 to 1 so that it initially runs after one step of the checkline function being called. Now I'll go ahead and add the alarm 0 event. And before coding that, I'll create another variable. This will store how many cells from the current row have been animated. It will begin at 0. Now let's go into alarm 0, and I'll jump over to when this event has been finished. And let's go through what this does. It first gets the X value that we need to access the correct cell from the grid, and that is the cell's animated value. It then gets the correct cell from the grid using our x value and the current line value as the y component. So we've got the cell, which is a struct, so we call the start animation function on it, which we will create very soon. Then it increases the cell's animated value by 1 because we have now animated one more cell. Then this condition checks if there are more cells to be animated, which means that the cell's animated value is smaller than the width of the grid. In that case, it sets the alarm 0 to run again with the animation delay value. But otherwise, if we have animated all the cells, it simply sets animating to false and doesn't call the alarm again. So this alarm will essentially run for each cell until we've animated all of the cells in the current row. Now let's go over to the classes script and create the required functions in the cell constructor. First, I'll create a variable, and this will be reveal. This will be a value from 0 to 1, and this will tell how much this cell has been revealed, where 0 is not revealed at all and 1 is completely revealed. Then let's create a static function called start animation, and this will set reveal to 0.01. And in our system, this basically means that the animation for this cell has begun, because the condition that we use to check if the animation has begun is simply checking if reveal is greater than 0. We'll add that in soon enough. Let's create another variable. This will be the reveal speed, which is the speed at which the cell is revealed. Down here I forgot the function syntax, so we need that. Now let's go into the draw function and here implement our reveal variable. Here I'll add a condition to check if reveal is greater than 0, meaning that the cell is currently animating, and I'll wrap this code in that condition. This code basically draws the colored rectangle for this cell. In Wordle, when a cell is being revealed, it flips over. We are going to work on that, but for now, just for testing purposes, I'm going to use the reveal value as the alpha for the cell, so it will fade in instead. So I'll add a draw set alpha function and set the alpha here to the reveal value. I'll add another draw set alpha call at the end to reset it to its default value. And after this code has run, I'll increase the reveal value by the reveal speed so it keeps going up. Although this should only happen if it is smaller than 1, so I'll add that condition. And if it isn't smaller than 1, then it should just be 1, not greater than that. Now let's run the game and see what we get. I'll enter apple, hit enter, and it's not animating at all. So there must be something wrong here. Let's see. In the checkline function, we should be resetting the cell's animated value to 0, so with each new row it starts animating from the first cell. So we should do that, but this is not what's causing the bug right now. Okay, so for each cell I printed the reveal value in the cell, and so here we can see the reveal value, which is currently 0 for all the cells, and this should help us debug what's going on. So when I enter apple and hit enter, you can see that the second row is what starts animating, not the first one. That's because after we enter the first line, it switches over to the second one, and because we use the current line variable for the animation, it starts animating the new line instead of the one that we entered last. So as a solution, we need to create a variable that stores the line that should be animated. So I'll call this animating line. Now in the checkline function at the bottom, I'll take this part and put this up here, which is before the current line variable is increased, and here I'll set the animating line to be equal to current line, and in the alarm 0 event we should get the cell from the animating line instead of the current line, and this should fix our issues. I'll also speed it up a bit by decreasing the animation delay to 40 and increasing the reveal speed to 0.04. Let's run the game now. I'll write apple, hit enter, and you can see that the cells are now animating. They are fading in one by one, and while they are fading in, you can't do anything else. So the animation is working pretty well. We should now work on making the cells flip like it actually does in Wordle. For that, I'll first remove the alpha calls because we don't want to fade in the cells anymore. And to flip the cells, I'll basically use some math here to modify the y value for the rectangle based on the reveal value. So with this math, basically the top end of the rectangle and its bottom end will switch places while the reveal value is going from 0 to 1. So this way the rectangle will flip. Let's run the game and see what we get. and we do see the effect. The colored rectangle within the cell is flipping, but it's not perfect right now, so let's work on making it look better than it is. The first improvement we need to make is that the colored rectangle should only be drawn when the cell has flipped over, which is when the animation is done halfway through. So I'll add a condition to this, which basically checks if reveal is greater than 0.5, and it only draws the colored rectangle if it is. Then we also want the outline for the cell to flip as well. Currently what we are doing is that we are drawing the outline for the rectangle in the draw event of our object. So let's delete this from here, and in our cell constructor, here before drawing the colored rectangle, let's draw the outline. So for this I'll just copy the line that we have here, paste it here, and set the last argument to true so it draws an outline instead. The outline should be drawn regardless of the animation, so I'll put this out of this block. Let's run the game and see what we get. Okay, so the whole cell is now animating apart from the text, which we will do in a second. The outline appears to be drawing behind the colored rectangle, so let's fix that. The statement for the outline should be drawn after this. And now let's also make it so the text is also scaled with the rectangle. So I'll change this draw text call to draw text transformed, which can scale the text that you draw. And for the x scale and y scale, I'll pass in local variables for those, which we will create in a second. Let's create the x scale and y scale variables. The x scale will be 1 because we are not animating it horizontally. And for the y scale, I'm going to use some quick maths. And we don't need the 0.5 here. Multiply this by 2 and this should do it. Let's enter Apple, and the cells are now completely being animated. They flip over, including the text in the cells. So the animation is now finished, and with this our Wordle project is also basically finished. Don't forget to go into the create event and disable the target word that you manually enter, and instead make it pull from the text file that we loaded. And also it would be a good idea to be able to restart the game if you want to try again. So in the step event, I'll add a condition that checks if the R key is pressed, and this basically restarts the room. I'll actually make this Shift R instead of just R because otherwise the game will restart whenever you enter R. So now run the game and start playing your own Wordle. Try to guess the word that your game has loaded and show it to your friends and family and get them to try and guess the word that the game has decided as the target word. You can of course now make this your own. You can go into the text file that you loaded, and if you want, remove all of the 5-letter words that are there and instead add your own words. Make it your own Wordle with your friends. Now during testing, each time you run the game, the first time you will get the same word while you are testing within GameMaker, because it makes it easier to test the same thing. But if you don't want that during testing, you can simply call the randomize function in your create event, and each time you test your game in GameMaker, you will get a different word. So that's it for our Wordle project. I hope you enjoyed this video. Check out my other tutorials here, and make sure to subscribe, and I'll see you in the next one.